Hi, we're going to have a quick video on atoms, relative atomic mass and number. So I'm going to use sodium as an example. So when you look at a periodic table, you will see sodium's symbol and it will have two numbers. So what do these numbers actually relate to? Well, we need to look at atomic structure first. So what are atoms made up of? So atoms are made up of protons, which have a positive charge. They are made up of neutrons, which have no charge at all, hence neutron, neutral. And we have negative charged electrons. Okay, so each of these particles has mass. So if we have a look at the mass of a proton, it has what is called a relative atomic mass of 1. Neutrons have a relative atomic mass of 1 as well. And electrons have mass, but it is so tiny we can practically forget about it. So we think of the mass of electrons as 0. Okay, so what has this got to do with the relative atomic mass and number? Well, if we have a look at the atomic mass, electrons really aren't going to come into it because their mass is practically 0. So atomic mass is all to do with the mass of the protons and neutrons in an atom. Now these particles exist in the nucleus of the atom. So because there are only protons in the nucleus and not electrons, the nucleus always has a positive charge. So these two are in the nucleus of the atom and the electrons orbit around the outside. So how does it relate to the numbers? Well, first of all, if we look at sodium, this number here is the number of protons that are in the nucleus. So if I was to draw the nucleus of sodium, so here we are, and I'm going to show my protons as red. So my protons are going to be red. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 protons in the nucleus of sodium. The rest of the mass is made up of the neutrons. So the number at the top is the relative atomic mass of sodium. So 23 minus 11 is 12. So my nucleus, in order to have a mass of 23, must have 12 neutrons. So I'm going to show my neutrons as blue. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 neutrons. 12 neutrons, 11 protons gives me a relative atomic mass of 23. Okay, so where do the electrons come into it? The electrons orbit around the outside of the nucleus in something called electron shells. Now I'm going to show my electrons as green. Now all atoms are electrically neutral, which means that they must have the same number of positive protons as they do have negative electrons, so that electrically they cancel each other out and leave you with a neutrally charged atom. So if I have 11 protons in sodium, I must have 11 electrons as well. So the electrons orbit around the nucleus in electron shells. Each shell can only hold a certain number of electrons. So the inner shell of any atom can only ever hold 2 electrons. So if I draw my inner electron shell, sodium, 2 electrons will fill that inner shell, but sodium has 11 electrons, so where do the other ones go? Right, so we have another shell around that. Now the shells after the first inner shell can hold 8. So 1, 2, 3, 4, 5, 6, 7, 8. Now that still only gives me 10 electrons. Sodium has 11. So we must have another electron shell. And in order to have 11 electrons, there must be another electron in the outer shell. And that will mean it has 11 electrons. How do we write that? So we write something called the electron configuration. So for sodium, the electron configuration is 2 for that full inner shell, 8 for the full middle shell, and 1 for the outer shell. It's got 1 electron in its outer shell, and that tells us that sodium is in group 1. All the elements in group 1 have 1 electron in the outer shell.